everyone. Either welcome back or welcome to my channel. Today's topic is going to be actually covering kind of what to look for if you ever happen to find scientific literature, especially on things like PubMed or anything, because not all scientific literature is actually created equal. Some of them can actually be pretty bad, and it's good to know what a good paper is compared to what a bad paper is. So let's get into the video. How do I know what I'm looking at is something I should be looking at? So this is where I can actually help you. So we spent a lot of time in university doing this type of exercise where we would be given a task where we'd have to search through the literature because scientific literature was the only stuff allowed. You just cannot trust anything that you read on basic internet searches anymore. It's too easy to put out whatever you want to into a scientific type sounding paragraph and have people convinced that it's the truth. When you're looking for particular things to be wary of, you're going to want to look at who the authors are and if they have any conflicts of interest or not. This can be done by searching more on the scientists involved. So if we were to find all of a sudden that we had a paper that just all of a sudden said risks to vaccinate were so much heavier than the benefits, you would start to wonder, okay, who's putting out this information and what is the purpose of this? Another good place to start is looking for publishing dates, because unlike other subjects, science is not in concrete. It can be challenged. There is nothing saying that you cannot go out and disprove something, because actually all hypotheses have to be falsifiable by definition. But when you start getting into a specific idea that really challenges something that's been so solid for so long, that's generally a pretty good red flag for many people. And I guess if it's something that you've read several years ago is a good place to start too. If it's a paper that is quite old and is quite heavily researched still today, it may not be the case that idea is still valid. I get a little hesitant when I see people reading scientific articles on PubMed, just because it's a very hard thing to learn how to do, is to read scientific literature. It's still really difficult for me. Even after graduating from my bachelor's degree, I still struggle with different parts of scientific literature because I honestly am lacking in my understanding of statistics. So if I was to actually do much more with this type of stuff now, I would actually consider doing more statistics classes, because honestly, some papers are truly heavy in statistics. And if you don't honestly know what those statistics really mean, the results really can't be criticized all that much if you don't really have the background to criticize it. If you've got person specifically telling you something you've heard from medical professionals all over again, such as exercise, eat healthy, stuff like that, and they're telling you, oh, well, you can get away with not exercising, but they have like a background in physics or something like that, it's probably best just to take their advice with a grain of salt, just because they don't really have that background to tell you, yes, this is 100% true, or no, it's not. It's not because they're not intelligent at all. It's just that it's not possible, I guess, to know absolutely everything about a subject. You gotta know where to say, I'm sorry, that's not my field of expertise. You might want to go talk to a ... You just shouldn't be touching on stuff that you just have no idea about, because it doesn't make you look very good. So that's another thing to look for, is who, I guess, has the background in that and what they've been actually studying. With scientific papers, you're not going to get that a lot. It's going to be in the general social media stuff. Almost everybody seems to give everybody nutrition advice. In Canada, the only people who are able to give nutrition advice that actually have a degree are registered dietitians. That is the way it works. That is the way they're licensed. But in Canada, if they don't have a RD, they shouldn't be giving out nutrition advice. Is just my best piece of advice for that. when it comes to other things to look for, you basically cannot get through a scientific paper without some type of background in statistics. They may help you through some information with statistics, but some of it, honestly, you're gonna struggle with it if you don't have that statistics background. So take your statistics early if you can in your degree, and definitely use it as an elective if it's not already a requirement. You don't want to be giving people the wrong advice. And when it comes to biochemistry and medicine are very heavy intertwined. So biochemistry has a very large impact on eventually medicine because of the fact that those are the drugs that doctors are eventually going to be prescribing. And they want to make sure that they're giving the right information as of what we know now in the research. You don't want to have studies only referencing case studies. So case studies are one where they look at only a few people at a time, and they're really, really small studies. When you have only a few people at a time, it really causes issues because you cannot extrapolate data from a small number of people to a population because of something called a normal distribution. So, a normal distribution in science basically is the bell curve. This is just going to be a hypothetical example. So, you're going to have where it slowly goes up, rises to a peak, comes back down. This is how IQ is determined. With this normal distribution, you're going to have exceptions to the rule, but there's going to be a general rule in the center that most people fall under. That's the most important thing to take into consideration. So, with this type of information, you don't want to have just a few people giving you information because those few people could just happen to be in those rare circumstances where you're actually finding that they are exceptions to the rule and you could be missing out on your whole center distribution and the whole purpose of what you're trying to study. It's biology, basically. There's always exceptions. Biology very rarely has anything that 100% applies to everyone because of the genetic diversity in the population, which is basically by how nature intends it to be. Having similar type of genetics is not ideal for reproduction. If you're gonna be trying to extrapolate your data to a population, or you're trying to determine is something significant, you're gonna want to have a very, very large number of people involved. And unfortunately, the best way to do those kind of studies, if you're talking about gathering of statistics, is surveys. I see a lot of people get mad on alternative medicine type websites where they reference information because the study information has come from surveys. I agree that surveys aren't the best, but unfortunately, it's the best thing we have to gathering a lot of information very quickly. So, until a new way of gathering information is available, this is what we basically have to work with. That's it for now. Also, if you subscribe by clicking the red button, you can get notifications on exactly when I upload my videos, so that you can watch it as soon as they're available. So it'll give you a little notification. I'm hoping to have this content eventually. I get used to the upload times and can give you a definite time. As for now, we aim for 5 p.m. Central Standard Time. Saskatchewan does not follow daylight savings time, so keep that in mind when the times change in the spring, that Saskatchewan stays on Central Standard Time. So this will be the same as Mountain Daylight Time, for those of you who are unfamiliar with Standard Time and Daylight Time information. Bye!